Forms of energy. The standard for forms of energy. Energy is involved in all physical processes and is a unifying concept in many areas of science. Energy exists in many forms and has the ability to do work or cause change. So, what is energy? Energy is simply the ability to cause change. Think about things that have energy in them. All of those things can make something do something. It's what causes everything to change. Nothing can change without energy causing it. Earthquakes, rain, human growth, it is all simply because of energy. So, what's the difference between potential and kinetic energy? Potential energy is the stored energy an object has because of its position or state, such as a bicycle on top of a hill, a book held over your head, or even a stretched out spring. They all have potential energy. Other examples of potential energy are elastic, electric, chemical, and nuclear energy. On the other hand, kinetic energy is a form of energy that results from an object's motion. There are many types of motion that use kinetic energy. Translation, that is simply moving from one place to another. There's also rotation and vibration. Other examples of kinetic energy is mechanical, electrical, light, sound, and thermal energy. But what's the difference between the two? Kinetic energy is the energy an object contains because of its motion. It is always in motion. On the other hand, potential energy is stored energy because of the state of rest. The object is at a state of rest. I've attached a video that explains the difference between potential and kinetic energy. Please feel free to come back and watch it at any time. The 7 basic forms of energy that we're going to cover are mechanical energy, heat, electrical, chemical, sound, nuclear, and light energy. Mechanical energy is often confused with kinetic and potential energy. Mechanical energy is the sum of kinetic and potential energy in an object that is used to do work. In other words, it is energy in an object due to its motion, position, or both. Heat energy. Heat flows from hot objects to cool objects. It flows from one object to another because of their difference in temperature. The cool object absorbs the energy and becomes warmer. Objects are made of particles or bits called molecules. Electric energy. Electricity is the flow of electrical power or charge. It is a secondary energy source, which means that we get it from the conservation of other sources of energy such as coal, natural gas, oil, nuclear power, and other natural sources, which are called primary sources. Chemical energy is released when bonds form in a chemical reaction, often producing heat as a byproduct. And this is also called exothermic reaction. There are 2 important terms to know in the study of chemical energy. The first term is exergic. That is simply a nuclear reaction that releases energy when the chemical bonds form. The second term is endoergic. That is simply an endothermic reaction and it requires an input of energy to take place. Other examples of chemical energy are batteries, biomass, petroleum, natural gas, and coal. Sound energy. Sound is the movement of energy through a substances in longitudinal waves. Sound is produced when a force causes an object or substance to vibrate. The energy is transferred through the substance in a wave. Sound is a type of energy made by vibrations. When any object vibrates, it causes movement in air particles. These particles bump into the particles close to them, which makes them vibrate, causing them to bump into more air particles. This movement, called sound waves, keeps going until they run out of energy. If your ear is anywhere within the range of those vibrations, you will hear sound. I have also attached a video on sound energy to explain in further detail. Please come back and watch it at any time. Nuclear energy is the energy in a nucleus or the core of an atom. Atoms are tiny particles that make up every object in the universe. There is an enormous energy in the bonds that hold atoms together. Nuclear energy can be used to make electricity, but first, the energy must be released. It can be released in forms of atoms in two ways: nuclear fusion and nuclear fission. Nuclear fusion is energy released when atoms are combined or fused together to form a larger atom. This is how the sun produces energy. Nuclear fission is when atoms are split apart to form smaller atoms, releasing energy. Nuclear power plants use nuclear fission to produce electricity. Light energy. The potential for light to perform work is called light energy. Light energy is the only form of energy that we can see directly. It is formed through chemical, radiation, and mechanical means. Light energy can also be converted into other forms of energy. Two misconceptions about energy. The first misconception: a lot of people like to believe that an object at rest has no energy. Well, that is just wrong, because when an object is at rest, every object has rest mass potential energy. If the object is in a position to be affected by gravity or falling, that is called gravitational potential energy. Once that object is in actual motion, the potential energy is converted then into kinetic energy, which we all know kinetic energy is when energy of motion is the energy, the object is now in motion. The second misconception is people like to believe energy and force. They like to believe that those two terms are interchangeable. Energy and force are not interchangeable at all. They are not even the same thing as each other. A force is a push or a pull of some sort. A true force is always in an interaction. That means that that force always comes in pairs. This is also stated in Newton's third law: equal and opposite forces. For every action, there must be a reaction. So, how can we connect the energy to our world? We've learned that heat energy is simply the sun when it radiates heat. Cooking on the stovetop, a toaster heating to cook toast. Sound energy can simply be any sound that we hear, such as a plane taking off, when an air conditioner is running, popping of balloons, or ringing of bells. Electric energy can simply be lightning, or batteries, a radio, light bulbs, or the computers we use every day for work, home, school. Chemical energy is simply coal, wood, petroleum, propane. Nuclear energy, don't forget, nuclear fission is the reaction at a nuclear power plant. It provides enough energy to give electricity to the large cities. On the other hand, the nuclear fission reaction is in the sun, and it provides our planet with all of the energy it needs for living organisms to survive. Mechanical energy is such as hydroelectric plants, steam engines, windmills, a dart gun, or even an electric motor. Light energy can simply be a light bulb, the glowing of coals of a toaster, the sun, or headlights on a car. So, what have we actually learned? We learned that energy is simply the ability to cause change. We know what the seven most common forms of energy are now: light, heat, chemical, nuclear, electric, sound, and mechanical energy. We know what's the difference between kinetic and potential energy. Kinetic energy is the energy an object contains because of its motion, and potential energy is the stored energy an object has because of its state of rest. We also know ways that we can connect the world that we live in to these seven forms of energy. Please feel free to go back and watch the two videos that was attached for further information.